Hello viewers! Today I'm going to show you how to start writing programs that use AI, completely free, without paying for tokens. It's really simple. You just need to know the basics of Python. The rest you'll see in this video and write your first program. Let's get started. At the beginning, we will visit the Groq site, the leader of the incredibly fast inference process. Why this particular site? Because Groq offers free API keys. These keys will allow you to use their computing power and artificial intelligence hosted on their servers, completely free of charge. This is the reason why the community of developers associated with their site is constantly growing. To make life easier for developers, they offer compatibility with OpenAI's API. This facilitates an easy start for those who are already familiar with the OpenAI API, as well as makes code more universal. See, they actually offer very high inference speed. They are leaders because they produce their own chips and offer inference as a service to the market. Of course, it costs money because that's their main business, as confirmed by their price lists. As you can see, they offer a large number of open source models that you can use with their API. For us, the most important thing is that they offer free keys for developers. Obviously, there are some limits, but that's not so crucial at the moment. Let's move on to the developer's console. I haven't been asked for login credentials because I had logged in before. You can easily do this if you have a Gmail account or any other email. By default, the playground opens, where you can choose which of the many models you want to work with. The selection is really vast, but for us, the most important is Llama 3.3 with 70 billion parameters. It's a very smart open source model by Meta. It's worth noting that on the list we also have Llama models in version 3.2 which offer vision. For example, Llama 3.2 with 90 billion parameters vision preview. A playground is an interface that allows you to test queries that can later be used in a program. It's like a chat, but with much greater control over the model's parameters. For a test, I'll ask something simple from my field. As you can see, the model responded very quickly. 207 tokens per second. If you've seen the video where I ran a 70 billion parameter model on my local computer, you'll notice just how huge the difference is. But we came here for the API key, so I'll generate it now. Of course, keep in mind that API keys are confidential, so mine will definitely be deleted before this video is published. Make sure not to share your API keys with anyone, even if you're not paying for them. After providing a clear name, I receive a string of characters that serves as a key. I copy it to the clipboard and will use it shortly. Now I'll set up a virtual environment for my program. If you've programmed in Python before, you're probably familiar with venv. In short, venv is used to manage the wealth of Python libraries, and to have those specific to a given program installed locally in a virtual environment. Both Python and venv are already installed, so I'm issuing the command to create the Groq test environment. This command will create the Groq test folder along with the necessary contents. The initialization takes a moment. Now I can enter the directory and see what its content is. As you can see, I have various directories here, including scripts. Since every time I want to use a virtual environment, I need to activate it. There's an appropriate script for this in the scripts directory. I still have the API key from Groq in my clipboard. It's time to create a file where I can paste it. It's not a good practice to store keys in the code, so I'll create a special file with environment variables to put it in. For my project, I will use the very convenient editor Visual Studio Code. It is completely free. I need to open my project folder that I'll be working on. This is Groq test. The new file will be named .env because that's the type of file used to store environment variables when using the load.env function. This is a very popular solution among developers. I name the variable Groq_API_key because this is a standard naming convention. Alright, the key is ready. By the way, when running the script, I should probably execute activate.ps1 instead, because this is the PowerShell and that way I can see that the environment has been activated. Although it doesn't really matter, because I'm about to close this shell session anyway. Time to write the first program. I'm heading back to the Groq website once more to check the documentation. I'll open the console again. The documentation is in the menu on the left side. I choose Groq Libraries because the native library interests me the most for now. I have the documentation for Python here. First and foremost, you need to install the library using pip install Groq. Below, we have an example of code. First, there's the import of the library, followed by the initialization of the client using the API key stored as an environment variable. Here is the invocation of the artificial intelligence model using 2 chat messages. The Llama 3.3 model with 70 billion parameters is also selected. Finally, the message returned by the AI is printed out. It's worth noting the data format. The content of the message is encapsulated in an object here. We have a choices array, and then the message object. That's why the message is printed in such a complex way. I think we already know enough to take the first step and write our own program using the Groq library. It won't be anything complicated since this is the first video in the series, so I'll focus more on a working example rather than functionality. I'm creating a new file called groqtest.py. To start, I'll enlarge the text a bit for better readability. I know some of the viewers watch videos on their smartphones. It's worth checking if the virtual environment has been activated. This is done automatically if the appropriate plugin is installed. Just to be safe, you can run the activation script. The documentation suggested the need to install the Groq package using the pip command. This can be done from the terminal in Visual Studio Code. It might take a little while because all the dependencies are being installed as well. The library has been successfully installed. Now you can additionally install .env module. It will be needed to load environment variables from the .env file. I think all the dependencies have been installed. Therefore, I'll close the terminal window for now to have more screen space for the program. I'll start with the obvious imports. From the package called Groq, I need the Groq class. I also need the OS module to manipulate environment variables. The last thing I need is the content of the .env package, specifically load.env. Now I can load environment variables from my .env file using the load.env function. Now we can finally focus on more interesting things. I need to initialize the Groq client. Of course, I'll need the API key for this, which I have in my environment variables. This is where the OS module comes in handy, as it allows you to retrieve an environment variable. You probably remember the name of the environment variable in the .env file. Now it's time to query the large language model. This is done by creating chat completions for the client. As you can guess, I'll need a prompt and a definition of which language model I want to use. We start with a prompt. Currently, every chat with artificial intelligence works in such a way that with each iteration, the entire conversation history is sent again. In my case, it will be a very simple conversation consisting only of a query from the user. A conversation consists of messages. Each message has a specific creator. Typically, this is either the user or the assistant, which is AI. Naturally, each message also contains content. To check the functionality of the program as well as the language model, I will ask about the transaction used for configuring profiles in SAP. Of course, I'm referring to RZ11, but let's see what the response will be. Yes, that's an obvious mistake because messages is an array that takes objects. Our conversation element is an object here, so I need to add curly brackets. Since indentation matters in Python, I still need to add it. Now it should be fine, but the model definition is still missing. Without it, Groq wouldn't know where to run my query. I'll go back to my developer console for a moment to check the name of the language model I want to use. Llama 3.3 70 billion versatile. So I enter this name. And that's basically it when it comes to chat completion. After this call, the query should go to Grok, and the response should be assigned to the chat_completion variable. The final element of the program necessary for it to function correctly is printing the result. Of course, the result that is placed in chat completion is a complex object, as we saw earlier in the documentation, and I only need to print the content of the message itself. In my opinion, the program is ready. Keep your fingers crossed because I'm about to run it. The result should appear in the terminal, and there it is. Of course, artificial intelligence knows that it's about the RZ11 transaction. Very good. As you can see, writing this program was very easy. Of course, this is just a simple example. For a specific application, it would definitely need to be expanded, error handling added, and so on. But it's a good starting point. To make writing the next program a bit easier, I'll copy these 3 lines into a new file. I showed you how to use the Grok libraries, and now I'm going to discourage you from using them. In such a rapidly evolving field, it's really beneficial to maintain as much universality and code portability as possible. Of course, it's challenging to pick an undisputed leader, but it's worth paying attention to the LangChain library. LangChain is currently a kind of standard, and will allow you to become somewhat independent from your AI service provider. You'll be able to use virtually any model, whether it's paid, free, or even local. That's why I'm currently installing LangChain, LangChain Core, and LangChain Grok packages. I'll be using them in my next program. I'll say right away that at first you'll notice that the program utilizing LangChain library is a bit longer. It might even seem a bit more complicated, but as you learn this module, you'll find that it's very logical and clear. I believe that learning LangChain from the start is only beneficial. Of course, it's always good to know how things work in their basic form, which is why the previous example was valuable too. The packages have already been installed along with their dependencies. It's always a good idea to start with the documentation, or at least know where to find it. The first link is what I'm looking for. This is just a small excerpt from the LangChain documentation regarding Grok. The documentation is quite good. It covers a lot of information, starting with which features are supported, through installation, and all the way to detailed usage with descriptions. The interesting part is chaining, which is actually where the library gets its name from, but we'll discuss that a bit later. Let's get back to our program, which we can start writing now. Here are the first 3 lines responsible for loading environment variables. Now we can define a variable to store the API key. Actually, we did the same thing in the previous program. I will now define the output parser. However, I will first need to import the appropriate class for that. You probably remember that in the previous program, we extracted the message from a rather complex structure. The output parser will do this for us, presenting clean text. As a reminder, I'll show you the structure I'm referring to. I mean it. The output parser is specifically responsible for extracting data from such an object. String output parser has been imported, so now I can use it in the definition of my parser. For now, it's just a definition. I'll use the parser later. I will define the template because it's very useful. But first I need to import it from LangChain Core prompts. Why from prompts specifically? Because it's a chat prompt template. The template is very useful, as you can guess, when we have repetitive prompts. The simplest method to create it is by using messages. In this case, we will use the simplest list of messages, which means just one from the user. The argument of the from messages method is an array, so even if there is only one message, we still place it in square brackets. Creating a template is very similar to creating messages, with the difference being that we can use variables inside curly brackets. It's these variables that make templates versatile and allow us to use them to make our work easier. In such a simple example, it might not seem very necessary, but it becomes highly appreciated as the complexity of the program increases. We already have an output parser and a template. What we're still missing is the model definition. The model is our AI engine. To define it, I need to import one more thing. It was shown in the LangChain Grok documentation. From LangChain Grok, I need to import ChatGrok. I can now return to defining my model as ChatGrok. When initializing the model, you need to provide similar parameters to those available in the playground. You definitely need to specify the model name, but you can also set things like temperature or the maximum number of tokens. Temperature affects how much creativity can drive the model. The lower the temperature, the more repetitive the responses are. Max tokens limits the maximum length of a response. This can be particularly important if you're using a more expensive model and paying for each token. Of course, we can't forget about the API key, which is very important here and associates the request with our account. I retrieve it from the environment variables. I just remembered that I had already retrieved the key from the environment variables, so I'll remove that line. And now I'll move on to defining a chain, something from which LangChain got its name. If you're familiar with Linux, you'll feel right at home, because the chain definition uses the notation known from shell and the pipe operator. Our chain is very logical. The starting point is a template that should be passed to the model, and the output from the model should be passed to the parser, which will return the result to us. Here you might start wondering what such a strange notation is doing in the middle of a Python program. Technically, this is implemented through operator overloading, but specifically, it is the LangChain expression language. Of course, there is documentation for this, and it is a very important part of the LangChain library. Even though the use of basic LangChain expression language notation is very intuitive, it's definitely worth reviewing the documentation. And here we have a description of composition syntax, including an explanation of the pipe operator. Obviously, at this stage, you don't need to worry about what a runnable is, but it's worth remembering the name if you're serious about learning LangChain. But let's get back to our program. Believe or not, it's practically ready. The final element needed for operation is the invocation of the chain. This is very straightforward, since we already have all the parameters and flows set. All that's needed is to assign a value to the variable topic, which is defined in the template. I will define my topic as SAP transaction ST22. The entire prompt based on the template will therefore read, define SAP transaction ST22 in one sentence. Of course, the result still needs to be printed. Thanks to having the proper output parser at the end of the chain, we'll get a clean text response as the result. The moment of truth. I'm launching the program. And success! I asked for one sentence, so I got one. But it is a very long sentence. Well, artificial intelligence can still be quite chatty. Let's now see the advantage of templates. All I need to do is change the topic in the final call to get a completely different result. It's often the case that a large portion of the prompt is shared, while only a very small part changes depending on what we want to achieve. In this way, instead of information about the SAP transaction, we have a single sentence about a pomelo. The Spanish probably have a different opinion about pomelo, because for them it's just grapefruit. ¿Te gustan los pomelos? Regardless of the considerations about fruits, we have a ready program. As I mentioned, LangChain might seem a bit excessive at first, but once you get to know it better, you'll definitely appreciate its clarity and logic. I highly recommend getting acquainted with this framework. Thanks to it, you are not tied to any specific LLM or provider, and you can easily create even complex programs. And if you're interested in agents, like my SAP GUI agent, a logical switch would be to a library from the same family, such as LangGraph. This will be very straightforward, knowing LangChain. On the other hand, Grok is also a very logical choice to start with. It's fast and free. It's a good place for initial experiments, and then you can decide if you want to go other way. If you have doubts about whether it's truly free, let's check one more thing. I'm heading over to my developer console, where all the important information can always be found. Next, I go to the settings section, and then I select billing to make sure that my plan is currently free. As you can see, it's free. But there's also information about low rate limits. Let's see what that means in the limits section. As you can see, each model has certain limits. For our Llama 3.370B, it's 30 requests per minute or 1,000 requests per day, with a limit of 6,000 tokens per minute and 100,000 tokens per day. Is that a lot? It's enough for initial experiments, but you definitely won't be able to build a production solution with it. When I check the usage, I see that some costs are associated with my account. It's not much for the experiments I just conducted. However, there is a clear amount in dollars. But if I scroll up, I can see information stating that it's just a calculation, if I were being charged. But my account is free, so this is not the case. So you have a good starting point. Now the rest is up to you. What I can advise is to try writing a program yourself, modify it, and then it will be easier from there. I hope you enjoyed this video format. If you did, please give it a like and subscribe to the channel. If there's enough interest, more videos in this series will definitely follow. May your programs always be bug-free and useful. See you next time.